Listening 8. Art History Class.
Listen to part of a discussion in an art history class. The professor is talking about action art.
In the 1950s, abstract expressionism emerged among a group of painters that came to be known as the New York School, although the members included artists from many regions of the United States and several European countries as well. In any case, we know that the brushstrokes were a significant feature of the work of Impressionist and Post-Impressionist painters, and like them, the abstract expressionists were interested in the expressive qualities of paint, and particularly in the case of action painters or gesture painters. They were sometimes called gesture painters, and they developed new methods for applying the paint. They dripped, threw, sprayed, and splattered paint on the canvas with a view to expressing artistic actions or gestures as part of the creative process. Now, according to your textbook, probably the best known of the action painters was who?
Pollock?
Jackson Pollock.
No doubt about it. Pollock was a highly individual artist. He's famous for huge mural-sized works, and to create them, he'd spread his unstretched canvas on the floor, and he'd approach the work from all four sides, walking around it and attacking it with commercial house paint in cans that he carried with him. He dripped the paint from sticks or brushes that he dipped in the cans, or he threw the paint and splashed it in patterns that reflected the motion of his arm and his body as he engaged in his so-called action painting. I think you can see how the name applies to this method. So Pollock claimed that this process allowed him to be in the painting, not apart from it. Let me show you a picture of Pollock with a work in progress. As you can see, and this is Pollock, he's stepping right onto the canvas, splattering and dripping the paint. He's focusing on the act of painting, and he's using grand rhythmic gestures, sort of similar to a dance. In fact, some critics referred to the work as a performance or a choreographed activity. He also used to pour the paint directly out of the can, and occasionally threw sand, broken glass, pebbles and string and other objects. He'd throw them onto the canvas. So, how much of the action art was a result of decisions, and how much was pure chance? What do you think?
Well, there was probably a little bit of both going on there.
Probably so. But Pollock contended that he could control the flow of the paint with the motion of his arm and body, and that his work was not accidental. And it certainly was spontaneous in the sense that it happened very quickly, and the decisions that he made were of necessity, split-second choices. So I'd say you're right that action art, and Pollock's work in particular, is a combination of chance, of artistic intuition, and control. And I should point out that he was known to retouch a drip with a brush on occasion. Now let me show you an example of the paintings themselves. What do you see?
There's no visual center of attention.
Which means?
Which means the image has no foreground, no background, no focus of attention.
I see. However, I think you'll agree that it does have a complex unity, a balance of form and color. Look at the patterns. Wouldn't you agree that they're caused by the separation and weaving of one pigment in another? And it was this weaving that produced a number of tones from a minimal palette of paints. Have any of you ever seen an original Pollock?
I have. I went to the Guggenheim Museum when I was in New York last year.
Could you tell the class a little about it?
Sure. I thought that the work looked like skeins of yarn because the dripping and the small objects produced
Texture?
Yeah, texture as well as form, like yarn. And I also remember the light that seemed to be in the canvas.
And precisely because of the texture and light, it's really a disservice to see this as a flat slide.
Oh, another thing. A lot of the paintings were identified by numbers instead of names.
Oh, thanks for bringing that up. Some people think he did that because he didn't want to limit the imagination. He wanted others to view a painting without prejudice, so to speak. But one piece has come to be called Lavender Mist. I'm not really sure whether Pollock actually named it or not, but it's particularly interesting because the artist marked the image with his handprints. I think it's in your textbook, but again, seeing it with the texture of the paint is a different experience. Okay, so after the process of creation, we see beauty, order, unity, perhaps even rhythm in an incredible light emanating from the canvas. Pollock wanted to express his feelings rather than to merely illustrate them, and I think he did achieve that. And whether you like them or not, and many critics argued and continue to argue their merits, but it's undeniable that works by Pollock are unique and recognizable, and virtually impossible to copy. It's also clear that he had a remarkable influence on later artists, color field painters who adapted the paint-pouring methods, and modern artists who chose to work with all-over patterns, and the performance artists who continue to push the envelope on activity and process.
40. What is this discussion mainly about? (41) To what did some critics compare Pollock's work? (42) According to the professor, what defines action art? (43) Listen again to part of the discussion, and then answer the following question.
Could you tell the class a little about it?
Sure. I thought that the work looked like skeins of yarn because the dripping and the small objects produced
Texture?
Yeah, texture as well as form, like yarn.
Why does the professor say this?
Texture?
44. What is interesting about the painting Lavender Mist? (45) What is the professor's opinion of Pollock?
Listening 9. Engineering class.
Listen to part of a lecture in an engineering class.
Because every earthquake presents us with unique conditions, it's difficult to anticipate the stresses that'll ultimately affect the structures we design and build. So our challenge is to try to design a building that'll be as safe as possible for all types of earthquakes. Besides that, during the past decade, the expectations for earthquake-resistant structures have changed. Whereas in the past, it was considered adequate for a building not to collapse during an earthquake, now, insurance companies and even clients, they're demanding buildings that'll be able to maintain their structural integrity through an earthquake and remain sound after the earthquake subsides. So in recent years, we've developed several techniques for building more earthquake-resistant structures. For relatively small buildings, all we have to do, really, is bolt the buildings to their foundations and provide some support walls. Remember, these walls are referred to as shear walls in your textbook. They're made of reinforced concrete, and by that I mean concrete with steel rods embedded in it. This not only strengthens the structure, but it also diminishes the forces that tend to shake a building during a quake. And in addition to the shear walls that surround a building, shear walls can be situated in the center of a building around an elevator shaft or a stairwell. This is really an excellent reinforcement. It's commonly known as a shear core, and it contains reinforced concrete too. Okay, let's talk about walls. Walls can also be reinforced using a technique called cross-bracing. Imagine steel beams that cross diagonally from the ceiling to the floor, and this happens on each story in a building. So before the walls are finished, you can see a vertical row of steel X's on the structure. And this cross-bracing tends to make a building very rigid and consequently very strong. But besides steel reinforcements, engineers have also devised base isolators, which are positioned below the building, and their purpose is to absorb the shock of the sideways shaking that can undermine a building and cause it to collapse. Most of the base isolators that are currently being used are made of alternating layers of steel and synthetic rubber. The steel is for strength, but the rubber absorbs shock waves. In higher buildings, a moat of flexible materials allows the building to sway during seismic activity, or large rubber cylinders support all of the corners of the building and in between each floor, and they allow the building to sway during an earthquake. So you can see that these alternatives are quite different from cross-bracing or shear walls. So the combination of reinforced structures and flexible materials has been proven to reduce earthquake damage. But even these engineering techniques are insufficient if the building's been constructed on filled ground. Soil used in fill dirt can lose its bearing strength when subjected to the shock waves of an earthquake, and the buildings constructed on it can literally disappear into the earth. So in areas where earthquakes are known to occur, it's important to understand the terrain, and you have to be sure that the ground's either solid or it's been adequately prepared. Okay, let's assume that we do everything right. We choose and prepare the construction site, and we design a building with plenty of reinforcements and flexible materials. With cross-bracing, we probably have a building with the strength to hold up under earthquakes, even those of relatively high magnitudes. And while this is great for the building, what about the occupants? Well, the structure may be strong, but the furniture will probably be overturned or shifted during the earthquake, and that could result in major injuries for the people inside. So, now that we've made progress in solving the problem of how to preserve the buildings, one of the more recent areas of research is how to better protect the occupants during an earthquake. One interesting possibility is to design buildings that house a series of pistons, and these pistons are filled with fluid and controlled by sensors in a computer. So, by analyzing signals from the sensors, the computer should be able to determine the magnitude of an earthquake in progress. And when it does that, it can trigger electromagnets in the pistons to increase or decrease the rigidity of the shock absorbers built into the structure. If the earthquake's minor, then the building can be programmed to sway gently, and the people and everything else inside get a safe ride. But during high-magnitude earthquakes, the shock absorbers can freeze the building to prevent it from shaking at all. So the beauty of the concept is that the computer sensors work very quickly, reacting within 1/1000th of a second. And they can run on battery power since the electrical system usually fails during an earthquake. Will the concept work? Well, the National Science Foundation is supporting more research into the potential of pistons, and the results so far are promising.
46. What is this lecture mainly about? (47) Which technique is used to reinforce walls? (48) Which two materials are used in base isolators? (49) What happens to fill dirt during an earthquake? (50) Listen again to part of the lecture and then answer the following question.
With cross bracing, we probably have a building with the strength to hold up under earthquakes, even those of relatively high magnitudes. And while this is great for the building, what about the occupants? Well, the structure may be strong, but the furniture will probably be overturned or shifted during the earthquake, and that could result in major injuries for the people inside.
Why does the professor say this?
And while this is great for the building, what about the occupants?
(51) What does the professor think about computer sensors for buildings? Model Test 5, Speaking Section. The speaking section tests your ability to communicate in English in an academic setting. During the test, you will be presented with 6 speaking questions. The questions ask for a response to a single question, a conversation, a talk, or a lecture. You may take notes as you listen, but notes are not graded. You may use your notes to answer the questions. Some of the questions ask for a response to a reading passage and a talk or a lecture. The reading passages and the questions are written, but most of the directions will be spoken. Your speaking will be evaluated on both the fluency of the language and the accuracy of the content. You will have 15 to 20 seconds to prepare and 45 to 60 seconds to respond to each question. Typically, a good response will require all of the response time, but the answer will be complete by the end of the response time. The time for the speaking section is about 20 minutes. A clock on the screen will show you how much time you have to prepare your answer and how much time you have to record it.
Number 1. Listen for a question about a familiar topic. After you hear the question, you have 15 seconds to prepare and 45 seconds to record your answer.
If you were asked to choose one place in your country where you would take a tourist, which one would you choose? Why? What is especially impressive about the place? Use specific reasons and details to explain your choice.
Please prepare your answer after the beep. Please begin speaking after the beep. Number 2. Listen for a question that asks your opinion about a familiar topic. After you hear the question, you have 15 seconds to prepare and 45 seconds to record your answer.
Some people believe that the best way to succeed is to set goals and work hard to achieve them. Other people think that hard work is not as important as good luck. Which point of view do you think is true, and why? Use specific reasons and examples to support your opinion.
Please prepare your answer after the beep. Please begin speaking after the beep. Number 3. Read a short passage and listen to a talk on the same topic. Then listen for a question about them. After you hear the question, you have 30 seconds to prepare and 60 seconds to record your answer.
A student meeting is planned to discuss the policy for vehicle registration. Read the policy in the college catalog printed on page 400. You have 45 seconds to complete it. Please begin reading now. Now listen to a student who is speaking at the meeting. She is expressing her opinion about the policy.
Well, I don't mind paying a parking fee, and I even think that $20 is reasonable. But my concern is that some of us are using more than one car. And since the registration's for the car, not the student, well, then you have to pay $40 so you can drive both of your cars on campus. But you're only one student. See what I mean? Like me, sometimes I have to take my husband's car, and one time last semester, I didn't have it registered and I got a ticket. I think that every student should pay a parking fee and then just put a parking permit on the windshield of whatever car the student is driving that day. Don't you?
The student expresses her opinion of the policy for vehicle registration. Report her opinion and explain the reasons that she gives for having that opinion.
Please prepare your answer after the beep. Please begin speaking after the beep. Number 4. Read a short passage and then listen to part of a lecture on the same topic. Then listen for a question about them. After you hear the question, you have 30 seconds to prepare and 60 seconds to record your answer.
Now read the passage about stress, printed on page 401. You have 45 seconds to complete it. Please begin reading now. Now listen to part of a lecture in a psychology class. The professor is talking about an experiment.
Let me tell you about a classic experiment on rats. I think it was first done in the early 70s by Weiss and reported in the Scientific American. Anyway, the rats were divided randomly into 3 groups. Rats in the first group were given shocks, but just before the shock was induced, they received a warning in the form of a tone. The second group of rats was also given shocks, but this group didn't receive the warning tone. And the final, control group, received no shocks, but they were exposed to the same warning tone as the first group. After a few weeks, the rats were examined, and the animals that had received shocks with no warning were already showing severe signs of stomach ulcers. The other 2 groups of rats showed little or no instance of ulcers. According to Weiss, the experiment confirmed that unexpected events are more stressful than those that can be predicted. In related experiments, there was also evidence that even a small amount of control over the circumstances surrounding the stress can lower the negative effects. When rats were allowed to select their own rest and feeding times, they experienced less physical damage than did rats that received the same amount of rest and feeding at times that were selected for them.
Explain the causes of stress and relate them to the experiment with rats.
Please prepare your answer after the beep. Please begin speaking after the beep. Number 5. Listen to a short conversation. Then listen for a question about it. After you hear the question, you have 20 seconds to prepare and 60 seconds to record your answer.
Now listen to a conversation between a student and her friend.
What are you going to do for the project?
I don't know. I was hoping you could help me think of something.
Well, you're such a good artist, you could talk about watercolor while you're doing one in front of the class. That'd be totally awesome. If I were you, that's what I'd do.
Maybe. But what if I make a mistake in front of everyone?
Come on, you're really talented. Besides, you wouldn't have to do much preparation beforehand.
True. And it fits in with what we've been talking about in class.
Yeah. Or how about this? You could bring in a photograph, a pencil drawing, and a watercolor of the same subject. Something simple so it wouldn't take so much time to do, like a flower. Then you could show the advantages and disadvantages of working with different materials.
I could do that one ahead of time.
You could, but remember, it'd take a lot more time.
Gee, thanks. I'll have to think about it, but these are both really good options.
Describe the woman's problem and the 2 suggestions that her friend makes about how to handle it. What do you think the woman should do, and why?
Please prepare your answer after the beep. Please begin speaking after the beep. Number 6. Listen to part of a lecture. Then listen for a question about it. After you hear the question, you have 20 seconds to prepare and 60 seconds to record your answer.
Now listen to part of a lecture in a geology class. The professor is discussing caverns.
Okay, as you'll recall, caves form in limestone when acidic groundwater follows some kind of weakness in the rocks. Now, the rock formations in a cavern, that's the technical name that we use for a cave. The rock formations there are of two kinds, stalactites and stalagmites. Both of these formations are water that contains dissolved minerals that accumulate and build deposits. But stalactites hang down from the ceiling of a cavern, and stalagmites protrude up from the floor of the cavern. Well, these words sound a lot alike, and this can be confusing. So I always tell my students to remember that there is a T in stalactites, and the T has a tail that hangs down just like the stalactites that hang down from the ceiling of the cave. But there is an M in stalagmites, and the points on an M stick up like the stalagmites that protrude up from the ground in a cave. And if that doesn't work for you, another way to remember the difference is that stalactite has a C in it, and so does the word ceiling, whereas stalagmite has G in it, and so does the word ground. So stalactites drip down from the ceiling, and stalagmites build up from the ground. So with these little tricks for remembering the difference, I expect you all to get this right on the next quiz.
Using the main points and examples from the lecture, describe the two kinds of rock formations in a cavern, and explain how the professor helps his students remember the difference between the two.
Please prepare your answer after the beep. Please begin speaking after the beep. Model Test 5, Writing Section.
First, read the passage on page 404 and take notes. Now listen to a lecture on the same topic as the passage that you have just read.
So now let's talk about how discipline relates to self-esteem. In studies of children, Coopersmith found that power and withholding of affection were associated with children who demonstrated low self-esteem. But management techniques were associated with children who exhibited high self-esteem. So it seems that parents should use physical punishment and withholding of affection with caution, right? Well, most psychologists oppose physical punishment for children under the age of 2, and some psychologists believe that discipline should be achieved without any physical punishment for children of all ages, referencing the fact that discipline means to teach, whereas punishment means to harm. Anyway, it's generally agreed that reinforcement of good behavior is more effective than waiting for bad behavior that requires punishment. But when discipline is necessary, setting limits with negative consequences that are consistently enforced seems to promote healthy development of self-esteem in children, especially when these management techniques are supplemented with approval, attention, and affection. I mean, when parents try to catch their children in the act of doing something right and use that as a basis for positive reinforcement of their behavior.
Model Test 5. Example answers.
Example answer for independent speaking question 1. A tourist attraction.
Although a case could be made for showing a tourist the beautiful mountain region or the historic capital city in my country, I'd probably take a tourist to my home, because living with a family would give this visitor a perspective about my country that few tourists have. Shopping, eating meals together, interacting and participating in the usual everyday activities, attending religious services, and visiting friends in their homes. This would let the visitor live in my culture for a while. I think this is more impressive than taking photos of places, because you can see all of the usual tourist attractions in videos or magazines, but you can't understand how people live unless you live with them.
Example answer for independent speaking question 2. Success.
I think it's important to set goals and work hard to achieve them. For one thing, goals help you think clearly about what you're doing. By identifying goals, you get organized. Another thing's the advantage of sharing goals with people who can help you. If others know what you're trying to do, sometimes they give you advice or assistance. As for good luck, I agree that a lucky opportunity or a chance meeting with a person who can help you is sometimes a key to success. But unless you know where you're going and what you want to achieve, you might not even recognize a lucky opportunity. So in my opinion, the best way to succeed is to know what you want and work to create your own good fortune. Then, if luck shines on you, you'll just reach your goal sooner.
Example answer for integrated speaking question 3. Auto registration.
To park on campus, students have to buy permits for each vehicle. They cost $20. The woman doesn't oppose the fee, but she believes that it should cover all the vehicles that a student might need to use. She uses a personal example from last term when she had to drive her husband's car and she got a ticket even though she had a paid permit for her own car. So her solutions to pay for parking on campus and then display the permit on the vehicle that the student happens to be driving that day. That way, if there are several cars in the family, the student can drive any of them using the same parking permit. In other words, she thinks that the $20 registration should be for the student who needs the parking space, not for the vehicle that the student's driving.
Example answer for integrated speaking question 4. Stress.
Stress is caused by changes in the environment that require people to adjust to new circumstances. It's interesting that these new conditions don't have to be negative. For example, you'd expect to have stress after a divorce or a health problem, but even moving to a new house or going on a trip can be stressful. Okay, in the experiment by Weiss, one group of rats was shocked after they heard a tone, so they knew that the shock was going to happen. Another group of rats heard the tone but didn't get the shock, and the other group received shocks at random without warning. So, the rats that received shocks without warning, they were the ones who developed ulcers, but the other two groups had fewer ulcers or none at all. And this research proved that unexpected experiences are more stressful than those we can predict. Additional investigations also showed that even a little bit of control, like choosing times to rest or eat, could reduce stress.
Example answer for integrated speaking question 5. Art project.
The woman's trying to decide what to do for her project, and her friend makes a couple of suggestions. He encourages her to paint a watercolor in front of the class while she's giving a talk about watercolor. The advantage of that project is she wouldn't have to prepare very much before the presentation. The other idea is to show 3 different versions of one subject, like a flower. In watercolor, a pencil sketch, and maybe a photograph. She could talk about the pluses and minuses of working in each of the 3 media. The advantage of the second project's that she could prepare it before class, but the problem is it'd be more time-consuming. I think she should go with the second idea because she seemed nervous about doing a spontaneous watercolor, and even though it'd take more time, showing the 3 pieces of art would be less stressful, and the advanced preparation might influence the professor to give her a better grade.
Example answer for integrated speaking question 6. Caverns.
The rock formations in caverns are made up of water that's saturated with dissolved minerals. As they drip and deposit themselves in the cave, you'll notice some of them hang from the ceiling and some of them grow up from the floor. The terms for each of these deposits are so similar that the professor suggests some tricks to help keep them straight. Stalactite has the letter T in it, which reminds students of a tail that hangs down. But stalagmite has the letter M in it, which brings to mind 2 points that stick up. He also points out that stalactite has a C in it, like the word ceiling. And stalactites drip down from the ceiling, but stalagmite has a G in it, like the word ground. And stalagmites grow up from the ground. So these memory aids, they help us recall that stalactites are the rock formations that grow down from the cavern, and stalagmites are the ones that grow up from the floor.
Model Test 6, Listening Section.
The listening section tests your ability to understand spoken English that is typical of interactions and academic speech on college campuses. During the test, you will respond to conversations and lectures. This is the short format for the listening section. On the short format, you will respond to 2 conversations and 4 lectures. After each listening passage, you will answer 5 to 6 questions about it. You will hear each conversation or lecture 1 time. You may take notes while you listen, but notes are not graded. You may use your notes to answer the questions. Choose the best answer for multiple choice questions. Follow the directions on the page or on the screen for computer-assisted questions. Click on Next and OK to go to the next question. You cannot return to previous questions. You have 25 to 30 minutes to answer all of the questions. A clock on the screen will show you how much time you have to complete your answers for the section. The clock does not count the time you are listening to the conversations and lectures.
Listening 1, Professor's Office.
Listen to a conversation between a student and a professor.
Hi, Dr. Davis. I'm a little early. Should I wait outside?
No, come on in. I'm free. What did you want to talk about?
Well, I've read the first couple of books you had on my list, the reading list for my independent study, and I was just wondering how you want me to report them to you. We didn't really talk about that.
Well, I'm glad you stopped by. Let me think. Didn't you have a project to do in addition to the reading list?
Yes. You said it could be a research paper, or I could come up with a proposal for a different kind of project.
That's right. So the reading list is background information, then. Why don't you just come in when you finish the first part of the list? I think it was divided in 2 distinct parts. So just come in, and we'll talk about the readings.
You mean I should prepare a synopsis of each book and kind of report to you on each one?
No. Nothing as formal as that. I was thinking more along the lines of a conversation. As I recall, the list has a focus, doesn't it?
Definitely. All of the books are novels and plays from the second half of the 20th century.
The postmodern period, then. And all North American novelists and playwrights.
Right.
So, We should be able to find some common threads then. Remember, though, postmodernism is very difficult to define precisely. Maybe we could start with a discussion of the themes that emerge in the collection of literature from that period.
That sounds interesting.
I think so, too. And by the time you get through with the second half of the reading list and we get together again, maybe we can figure out whether we're looking at a logical extension of postmodernism or whether there's actually a new movement there in the readings on the second part. If you'll notice, there are quite a few minority writers represented, so you might want to think about what that means.
I noticed that in the list. The first part of the list has the usual North American writers and, of course, a good representation of women writers, as you'd expect. But the second part of the list includes a number of African American authors, several Hispanic American writers, and a few Oriental Americans.
It's a multi-ethnic mix.
Yeah.
Good. So, have you decided whether you want to do a paper or something else, perhaps?
To tell the truth, I'd really like to do something a little more creative. Maybe bring in some visuals on the computer as part of the, I suppose you'd call it a mixed media report. But I've never done anything like that before.
But that's what an independent study is designed to do. It's an opportunity to experiment and to have some one-on-one time with a professor.
But a research paper is easier in some ways. At least I know that I can do a decent job. The computer project's unknown territory.
True, but remember, it's unknown territory for all of us. I think I've heard some references to cybermodernism. If you want to investigate some of the work that's being created in, as you call it, mixed media literature.
Cybermodernism? Wow.
I think you'd find it interesting. Anyway, it's up to you. It's your project.
Thanks. I'm really excited about doing this independent study. Actually, I'm spending more time on it than on any of my other classes.
I've found that students usually invest more time and energy in a class that they can design. That's why I like to direct them. Oh, and Terry, if you run into any problems, don't wait until you're halfway through your reading list. Just stop by during my office hours. Maybe I can give you some references or at least a sounding board.
Thanks. This is better than I even expected.
1. Why does the man go to see his professor? Two. How is the second part of the reading list different from the first part? Three. Listen again to part of the conversation and then answer the following question.
I think I've heard some references to cybermodernism. If you want to investigate some of the work that's being created in, as you call it, mixed media literature.
Cybermodernism? Wow.
What does the man mean when he says this?
Cybermodernism? Wow.
4. What will the man probably do before the next meeting? Five. What can be inferred about the professor?
Listening 2. Environmental Science Class.
Listen to part of a lecture in an environmental science class. The professor is talking about wind power.
Today I want to talk with you about another renewable source of energy, wind power. This isn't a new concept. In fact, wind's been used for centuries to pump water and launch sailing vessels. But more recently, wind power has been used to generate electricity. By the year 2000, California was using maybe 15,000 wind turbines to produce about 400 megawatts of electricity. And that was happening at a cost that would be considered competitive with coal or nuclear power. And although California currently leads the United States in harnessing wind power, there are several other areas that also hold considerable potential for increased production. Texas and the Dakotas alone have enough wind potential to power the nation. But since the winds there are so variable, well, wind power alone would be unreliable as a primary source of continuous energy. Nevertheless, it could be used as a secondary resource, along with fossil fuels. The strong and steady winds of the Pacific Northwest, especially in the Columbia River Basin, these winds would be ideal as a supplement to hydroelectric power when the river's experiencing periods of low water levels. Studies by the U.S. Department of Energy indicate that wind power generated from the Great Plains in the middle of the country could supply the continental United States with almost 75% of the electricity required for the region. In another section of the same report, it was noted that wind powers the world's fastest-growing energy source. Since 1998, the capacity for wind energies increased by more than 35% worldwide. And improvements in wind turbine technology in the past couple of decades has improved efficiency, cutting the cost dramatically from roughly 40 cents to about 4 cents per kilowatt hour. And a new turbine designs being tested with a lower torque, so that may actually move the price closer to 3 cents. Europe currently accounts for over 70% of the world's wind power. India, China, Germany, Denmark, Italy, and Spain have published plans for major increases in wind-generated electricity projects in the next few years, and recent interest and exploration have been initiated in the United Kingdom and Brazil. Remote areas, especially islands, and other regions at a distance from electrical grids are vigorously exploring wind options. Clearly, the global implications, not only for cheap energy, but also for clean energy, could be enormous. And in some areas, the consumers are even willing to pay a subsidy for the pollution-free energy that wind provides their communities. In Colorado, for instance, through a program called WindSource, about 10,000 customers pay an additional $2.50 per month for every 100 kilowatt hours of wind power. Legislation in several states in the United States now requires utility companies to guarantee that a percentage of their electricity will be generated from renewable sources like wind power. Of course, there are some problems associated with wind power that do need to be considered. The blades on the turbines present a hazard to migrating birds. In some cases, the vibrations interfere with television reception in the area. And there's been objections to wind farms because they produce noise and because they're not visually appealing to residents nearby. So in addition to the studies to improve turbine design and energy efficiency, some of the attendant problems also require research and development. Regarding the noise, let me mention that design modifications, basically modifying the thickness of the turbine blades and making adjustments to the orientation of the turbines, these modifications have diminished the noise substantially in a number of sites. As for visual appeal, some creative ways to share the land to create a more attractive wind farm are being piloted. So that brings us to the issue of storing wind power. And although wind energy can be stored temporarily as battery power, the real challenge for wind power exploration will be how to level out the energy source. Alternatives for storage will be critical because even in an area with steady winds, wind's still not totally reliable. But the TELUS Institute has released promising results from studies to investigate the problem of intermittent wind. This is what they did. By dividing the wind turbines from one farm into two smaller farms with geographical separation, the capacity of the pair of farms increased by 33.33% over the efficiency of the larger farm with the same number of turbines. So, by taking advantage of the slightly different wind patterns, a more continuous supply of wind power can be generated. So, where are we with all of this? Well, the research that'll make wind power a viable option is underway, but we need to continue to study in order to solve some of the problems before we can use wind power as a primary source of energy globally.
6. What aspect of wind power is the lecture mainly about? 7. Which two regions of the United States have the greatest potential for supplying wind power? Eight. Listen again to part of the lecture and then answer the following question.
Europe currently accounts for over 70% of the world's wind power. India, China, Germany, Denmark, Italy, and Spain have published plans for major increases in wind-generated electricity projects in the next few years, and recent interest and exploration have been initiated in the United Kingdom and Brazil.
Why does the professor say this?
Europe currently accounts for over 70% of the world's wind power.
Nine. In the lecture, the professor identifies several problems associated with wind power. Indicate whether each of the following is one of the problems mentioned. Click in the correct box for each phrase. Ten. How did the TELUS Institute solve the problem of intermittent wind? 11. What is the professor's opinion about the future of wind power?
Listening 3. Philosophy class.
Listen to part of a discussion in a philosophy class.
The earliest Greek philosophers, also known as the pre-Socratic philosophers, they were very interested in determining the nature of the universe. Initially, Thales proposed that water was the original material from which all other material was derived, and by that he was referring not only to things on earth, but also in the heavens. He observed that life sprouts from a moist ground, unlike death that dries and shrivels into dust. The fact that water could transform itself into a solid, as it does when it freezes into ice, or it could change into air as it does when heated into steam, well, this convinced him that everything had originated as water and would eventually return to water. He believed that all things are living things, including rocks and metals, and so literally everything would transform itself into the original material, water, in a logical pattern of change. A little later, Anaximander, and he was a student of Thales, so Anaximander was set on a path that involved questioning which of the elements was the most basic or fundamental. But he suggested that the universe was not originally made up of water, as Thales had reasoned, but was a living mass, which he called the infinite. The word in Greek actually means unlimited, but most translators have used the term infinite since it probably captures the meaning a little better in English. So, Anaximander put forward what some believe is the first theoretical postulate, that the infinite was constantly in motion, up and down, back and forth. So, although the infinite had begun as a whole, the motion had caused pieces to be broken off to form all of the elements of the universe, the earth, the sun, stars. Then, he speculated that as the oceans had begun to evaporate, the first sea plants and animals had formed, and from them, their descendants, the birds and land animals, evolved, until finally, mankind was created.
That sounds a lot like evolutionary theory.
Yes, it does. Probably the first instance of evolutionary theory among Europeans, although the Chinese philosophers had discussed this possibility earlier. Okay, so what do you think he postulated about the continued motion of the universe? Anyone?
I remember that part. He thought that all of these separate elements would eventually be put back together into the original infinite mass.
Precisely right. But good students think for themselves, and some years later, Anaximander's student, Anaximenes, criticized his teacher's view. He deduced that the original element of the universe was air, which was timeless and boundless, and in fact, alive. Because mankind and all the animals must breathe air in order to survive, he believed, therefore, that air had been transformed into blood, bone, and flesh. He also concluded that air was the origin of water, stone, and earth, and I think you can see the analogy with the parts of the body there. Furthermore, he contended that the solid condensations of air constituted the body of the world, but the ethereal quality of air constituted the spirit of the world, and it was the spirit that remained alive forever. Now, these three philosophers, Thales, Anaximander, and Anaximenes, they were all residents of Miletus, and were very active beginning about 600 years before the Christian era. So, they were called the Milesian philosophers, and they all had different views, but they also had something in common.
Do you mean that they were all materialists? Because they were trying to explain the universe in terms of perceivable elements like water and air?
Good observation. Let's take that a step further. They all attempted to explain the unknown in terms of the familiar, instead of looking to the current mythologies or to a divine presence. And that's what is truly extraordinary about these pre-Socratic philosophers. A naturalistic account of the cosmos was profoundly different from the myths and legends of gods and goddesses that had been the basis for explaining the origin of the universe.
So what do you mean by naturalistic?
I mean that they tried to use scientific arguments, and this marked a very new way of thinking. Unlike the exciting narratives of superhuman beings with the powers to create and change the universe, they proposed that the universe was made up of something very basic, and that it was constantly undergoing natural changes. The Milesians made a major contribution, and they did this by moving beyond the old mythologies and folk tales, and some scholars even suggest that they were responsible for the beginnings of Western philosophy as we know it. Now, when we talk about philosophy, it's important to point out that for many centuries, philosophy was not a separate discipline from other areas of thought and knowledge. In fact, early philosophers were mathematicians, physicists, chemists, and biologists before any of these sciences were identified as separate subjects or fields of study. So the pre-Socratic philosophers were trying to discover a scientific basis for the universe long before the scientific method and the technologies were available to support their investigations. But really, many scholars argue that these philosophers did initiate the process, at least, and the process eventually resulted, years later, as the beginning of the physical sciences. Okay, all of this appears on the surface to be very positive, right? But at the time, many philosophers, as well as ordinary citizens, were feeling much less comfortable with the very sparse tenets of emerging science than they had been with the rich and complicated stories that had explained the universe for them. Remember that this is all before Socrates, Aristotle, and Plato, who were, by then, more able to expand on proto-scientific thought and produce a massive and elaborate scientific alternative to the ancient beliefs.
12. What is the discussion mainly about? (13) Why does the student mention evolutionary theory? 14. Listen again to part of the discussion and then answer the following question.
Do you mean that they were all materialists? Because they were trying to explain the universe in terms of perceivable elements like water and air?
Good observation. Let's take that a step further.
Why does the professor say this?
Good observation. Let's take that a step further.
15. What view did the three Milesian philosophers share? (16) What can be inferred about the early Greek philosophers? (17) Listen again to part of the discussion and then answer the following question.
Okay. All of this appears on the surface to be very positive, right? But at the time, many philosophers, as well as ordinary citizens, were feeling much less comfortable with the very sparse tenets of emerging science than they had been with the rich and complicated stories that had explained the universe for them.
What does the professor mean when she says this?
Okay. All of this appears on the surface to be very positive, right?
Listening 4. Professor's office.
Now listen to a conversation between a student and a professor.
Excuse me, Professor Jones. I was wondering whether I could talk with you for a minute. If you're busy now, though.
Sure, Ann. What's up?
Well, I've been working on my research project. I'm doing it on decaffeinated beverages.
Oh, I remember. That's going to be interesting. How's it going?
Good. I've got all the data, but the report's turning out to be fairly short. It took such a long time to do the research, I thought I'd have a lot more to write about.
Well, how long will it be, do you think?
Probably 5 or 6 pages, and that includes a couple of pages with charts in them.
That sounds about right.
It does?
Yes. Oh, of course, it depends on what you included in the 5 pages. The issue here is whether the research design was well thought out and whether you have all the information in your report that you need to explain what you did, the approach, and the results that you found.
Okay. I have a short introduction, just a few paragraphs, really. So that's about caffeine. And then I talk about the benefits of decaffeination and several ways to do that.
Uh-huh. What else?
Well, I explain my research design, and that's sort of a problem, too, because I'm not sure whether to make this sound like a book, you know, the way the studies are explained in our textbook, or whether I should just write it up as clearly as I can so that anyone would understand what I did.
I'd go for that option. In fact, why don't you ask a few friends to read it before you turn it in? If your friends get it, that's a good indication that you've explained it well. But if they have a lot of questions, then maybe you need to do some rewriting. And Anne, it's even better if your friends aren't chemistry majors like you are.
Well, I would never have thought of that.
Then I'm glad I suggested it. By the way, did you include references at the end of your study?
Just 2. That's all I used.
Okay, good. Just as long as you cite the references you used.
Well, thanks. This is the first time I've ever done my own research. It was hard because I didn't have any experience, but it was fun, too. I was thinking about trying to get a part-time job as a lab assistant next year.
I think you'd be a good candidate. In fact, why don't you write up a draft of that report and I'll look it over for you before you hand in the final copy.
That would be perfect. I could bring it in on Monday since that's when you have your usual office hours. Would that be okay?
Yes, but that'd only give you 1 day before the report's due.
Oh, right.
Okay, then, why don't you bring it to class on Friday?
It'd be great.
And Anne, if you're really serious about that lab assistant position, I can give you some information about that when I see you.
Oh, I can't thank you enough.
Not at all, Anne. You've got a lot going for you. I'm glad to help.
18. Why does the woman want to talk with her professor? (19) What advice does the professor give the woman? (20) What does the professor offer to do? 21. Listen again to part of the conversation, and then answer the following question.
I could bring it in on Monday, since that's when you have your usual office hours. Would that be okay?
Yes, but that'd only give you 1 day before the report's due.
Oh, right.
Why does the professor say this?
Yes, but that'd only give you 1 day before the report's due.
(22) What is the professor's opinion of the woman?
Listening 5. Biology class.
Listen to part of a lecture in a biology class. The professor is talking about bacteria.
Bacteria is the common name for a very large group of one-celled microscopic organisms that we believe may be the smallest, simplest, and perhaps even the very first forms of cellular life that evolved on Earth. Because they're so small, bacteria must be measured in microns, with 1 micron measuring about 0.00004 inches long. Most bacteria range from about 0.1 microns to about 4 microns wide and about 0.2 microns to almost 50 microns long. So, how can we observe them? I'll give you one guess. Under the microscope, of course. As I said, bacteria are very primitive and simple. In fact, they're unicellular, which means that they're made up of a single cell. We think they probably evolved about 3.5 billion years ago. Some of the oldest fossils are bacterial organisms. They've been found almost everywhere on Earth, including all the continents, seas, and freshwater habitats, and in the tissues of both plants and animals. Well, since they're so prevalent, you might ask, how do they reproduce? Okay, they grow in colonies and can reproduce quite rapidly, in fact, by a process called fission. In fission, the cell, and remember, there's only one in bacteria, one cell. So the cell increases in size and then splits in 2 parts. Fission's also referred to in your text as asexual budding. Now, you'll also read about conjugation, and that's when 2 separate bacteria exchange pieces of DNA. So there are 2 ways that reproduction can occur, but we think that fission's more common. Okay, bacteria were virtually unknown until about 1600, when microscopes were introduced. And at that time, bacteria were observed and classified into 3 main types according to their shapes. And that classification hasn't really changed that much over the years. So that's what I want to talk about today, the main types of bacteria. The slides that I'm going to show you are enlargements of bacteria that I observed under the microscope in the lab earlier today. Now, this first slide is an example of bacilli. The bacilli are a group of bacteria that occur in the soil and air. As you can see, they're shaped like rods. And if you were to see them in motion, they'd be rolling or tumbling under the microscope. Of course, you can't see that because this is a still visual. But later, when you go into the lab, you'll see that rolling motion in examples of bacilli. These are kind of a greenish blue, but some are yellow. So don't try to identify them by their color. Look at the shape. These bacilli are largely responsible for food spoilage. Okay, the next slide's a very different shape of bacteria. It's referred to as the cocci group, and it tends to grow in clusters or chains, like this example. This specimen's one of the common streptococci bacteria that cause strep throat. Finally, let's look at the spiral-shaped bacteria called the spirilla. This is the spirilla. They look a little like corkscrews, and they're responsible for a number of diseases in humans. But I don't want you to get the wrong idea. It's true that some species of bacteria do cause diseases, but for the most part, bacteria are benign. There's a lot of bacteria in this room, in fact. We all have it on us. They live harmlessly on the skin, in the mouth, and in the intestines. In fact, bacteria are very helpful to researchers because bacterial cells resemble the cells of other life forms in many ways and may be studied to give us insights. For example, we have a major research project in genetics here at the university, Since bacteria reproduce very rapidly, we're using them to determine how certain characteristics are inherited. Okay, now, let me review these three types with you. Cocci are spheres, bacilli are rods, and spirilli are spirals. One of my students came up with a way to remember them. Just try to visualize the first letter in the name of each of the different types. Cocci starts with C, like the shape of half a sphere. Bacilli starts with a straight line on the B, and a rod is straight. Spirilla starts with an S, and that's a spiral shape. If it helps you, use it. In any case, although I want you to know the three major classifications, within these basic groups there are virtually hundreds of variations that make them somewhat more difficult to identify and classify than the rather straightforward specimens that I showed you a minute ago. Because you see, bacteria can join in chains, clusters, pairs, and sometimes more than one type of bacteria may be found together in a specimen. I think you get the picture. Okay then, in addition to identifying bacteria by their shape, which we now know isn't really a very good method for distinguishing them easily, if we really want to identify what type of bacteria we're dealing with, it's better to study the biochemistry or genetic structure of the specimen. They have one chromosome of double-stranded DNA in a ring, which we can analyze fairly easily.
23. What aspect of bacteria is this lecture mainly about? 24. Which of the following slides contain cocci bacteria? 25. Which two characteristics are common in bacteria? 26. Why are bacteria being used in the research study at the university? 27. How does the professor help the students to remember the types of bacteria? 28. Listen again to part of the lecture and then answer the following question.
Because you see, bacteria can join in chains, clusters, pairs, and sometimes more than one type of bacteria may be found together in a specimen. I think you get the picture.
Why does the professor say this?
I think you get the picture.
Listening 6. History class.
Listen to part of a lecture in a history class.
Frontier home design in the United States was greatly influenced by the provisions of the Homestead Act of 1862. The legislation gave settlers the right to open land, but mandated that homesteaders build a structure that was at least 10 by 12 feet and included at least one glass window. And they had to live on their homestead and improve the land for 5 years before their claim was recognized. Of course, when they first arrived, most homesteaders lived in their wagons or pitched tents until they filed claims and planted crops. And even then, knowing that fully half of the homesteaders wouldn't make it through the 5 years required to complete their claims, homesteaders tended to view the construction of their homes as semi-permanent dwellings. More likely, they'd build something better later or try to improve on what they'd built initially if they made it through the first 5 years. So, in addition to the requirements in the Homestead Act, the settlers needed a home that was easy to build, cheap, and maybe even disposable. Well, the log cabin's the construction that comes to mind when we think of Western settlements. But the plains and the prairies had so few trees that log construction was almost impossible. So the sod house was a practical solution for homesteaders on flat, treeless land. So how do you build a sod house? Well, First, you wait for a rain that makes the earth soft. Then you use a sod cutter to form sod bricks about 2 or 3 feet square and a few inches thick. Then you stack the bricks to form walls and weave branches or twigs and grass into a roof that's finally covered with sod as well. Now, there were tremendous advantages to this type of construction. In the first place, it was very cheap. There are journals from the 1800s that document construction prices at about $2.50, and most of that was for the glass window. And it took very little time to build, probably a day or two, and the thick walls actually kept the house quite cool in the summer and fairly warm in the winter. If a better home could be built later, the sod house would simply dissolve into the soil. But there were serious disadvantages as well. Even well-built roofs leaked onto the dirt floors, forming mud puddles, and sometimes the roof even collapsed from the water weight. Or in dry spells, the dirt crumbled from the roof into the home, not to mention the infestations of insects and even snakes that inhabited the dirt walls. So, those settlers who arrived in wooded areas opted to build log cabins instead of sod homes. Like the sod construction, the log cabin could be built in a few days, using simple tools, often only an axe. But it was much more comfortable. There's evidence that the first log cabins were introduced by Swedish settlers as early as the 1700s, but other immigrant settlers quickly adopted the construction. First, you build a foundation of rocks to keep the logs away from dampness that might cause them to rot. Then you cut down the trees and square off the logs, cutting notches in the top and bottom of each end so they could fit together when they were stacked at the corners. And it also had the advantage of assuring structural integrity. And there were several types of notching techniques that were used, depending on the skill of the builder. In any case, with notching, no nails were required. And that was good, since nails had to be shipped into towns and then transported out to the new settlements. But there were gaps in the walls, so these had to be filled by a technique called chinking. In chinking, grass, hay, moss, and mud were worked into rolls about 1 foot long and maybe 4 inches wide, and then they were inserted into the cracks between the logs. These rolls were commonly referred to as mudcats and were very effective in keeping out the cold and keeping in the heat. Of course, the tighter the logs, the fewer chinks were required, and that's important because the chinks were the weakest part of the cabin. And with the expansion and contraction that resulted from freezing and thawing, well, chinking tended to deteriorate and needed constant maintenance and repair. Okay, there was usually a stone or brick fireplace along one wall, and the roof was usually made of wood shingles. So you can imagine this was quite an improvement over the sod house. The advantages were that the home could be kept clean. Even though the floor was usually dirt or gravel because flat boards were difficult to obtain, it was still an effective shelter to keep out the rain and dust. Later, at the end of the 1800s, when the railroads brought materials such as asphalt shingles, tar paper, and finished boards to the frontier, the sod house was abandoned for one-room board shanties covered with tar paper. Whether this was an improvement is subject to debate. For one thing, since they were often built without foundations, the harsh winds of the prairies literally blew the shanties away. Still, many settlers considered the shacks preferable to the old soddies, even though they weren't as easy to heat and cool. To go back to the log cabin for a minute, the effect of new construction materials on the log cabin was aesthetic, as well as practical. The logs were often covered on the outside by finished boards and on the inside with plaster, which gave the cabins a more finished look and improved insulation. And by this time, the old one-room 10-by-12 was also being replaced with larger homes with several rooms. The frontier settlers had weathered the hardships of their first 5 years. They'd received their claims, and they and their homes were a permanent part of the great Western expansion.
29. What is the lecture mainly about? 30. How does the professor organize his lecture? 31. 31. What does the professor imply about construction materials for early homes? 32. What is the evidence for the inexpensive price of a sod home? 33. Listen again to part of the lecture and then answer the following question.
Later, at the end of the 1800s, when the railroads brought materials such as asphalt shingles, tar paper, and finished boards to the frontier, the sod house was abandoned for one-room board shanties covered with tar paper. Whether this was an improvement is subject to debate.
Why does the professor say this?
Whether this was an improvement is subject to debate.
(34) In the lecture, the professor identifies attributes for different frontier homes. Indicate whether each attribute refers to a sod house or a log cabin. Click in the correct box for each phrase. Model Test 6. Speaking Section. The speaking section tests your ability to communicate in English in an academic setting. During the test, you will be presented with 6 speaking questions. The questions ask for a response to a single question, a conversation, a talk, or a lecture. You may take notes as you listen, but notes are not graded. You may use your notes to answer the questions. Some of the questions ask for a response to a reading passage and a talk or a lecture. The reading passages and the questions are written, but most of the directions will be spoken. Your speaking will be evaluated on both the fluency of the language and the accuracy of the content. You will have 15 to 20 seconds to prepare and 45 to 60 seconds to respond to each question. Typically, a good response will require all of the response time, but the answer will be complete by the end of the response time. The time for the speaking section is about 20 minutes. A clock on the screen will show you how much time you have to prepare your answer and how much time you have to record it.
Number 1. Listen for a question about a familiar topic. After you hear the question, you have 15 seconds to prepare and 45 seconds to record your answer.
In your opinion, what are the characteristics of a good son or daughter in a family? Use specific examples and details to explain your answer.
Please prepare your answer after the beep. Please begin speaking after the beep. Number 2. Listen for a question that asks your opinion about a familiar topic. After you hear the question, you have 15 seconds to prepare and 45 seconds to record your answer.
Some people are attracted to jobs that include a great deal of travel. Other people prefer jobs that allow them to return to their homes every evening. Which type of job opportunity would you prefer, and why? Use specific reasons and examples to support your opinion.
Please prepare your answer after the beep. Please begin speaking after the beep. Number 3. Read a short passage and listen to a talk on the same topic. Then listen for a question about them. After you hear the question, you have 30 seconds to prepare and 60 seconds to record your answer.
The professor's attendance policy is published in the course syllabus. Read the policy in the course syllabus printed on page 450. You have 45 seconds to complete it. Please begin reading now. Now listen to a student who is talking with friends about the policy.
On the one hand, it's good that you can be absent once without explaining why. But on the other hand, you can't be absent more than one time without getting a lower grade. So I'd rather have the option of explaining my problem to the professor if I need to be absent, and then try to figure out a way to make up the work. Look, if I'm sick for 2 weeks, I don't think it's fair for the professor to lower my grade as long as I keep up with the class. Or if you have a legitimate reason not to be there, like a family emergency or something, I don't think you should have to choose between your health or your family and your grade in the class.
The student expresses his opinion of the professor's policy for excused absences. Report his opinion and explain the reasons that he gives for having that opinion.
Please prepare your answer after the beep. Please begin speaking after the beep. Number 4. Read a short passage and then listen to part of a lecture on the same topic. Then listen for a question about them. After you hear the question, you have 30 seconds to prepare and 60 seconds to record your answer.
Now read the passage about insects, printed on page 451. You have 45 seconds to complete it. Please begin reading now. Now listen to part of a lecture in a biology class. The professor is talking about insects.
Strictly speaking, a spider is not an insect. True, it's an invertebrate and an arthropod, but it belongs to a class identified as arachnids. Arachnids are not included in the insect world because their bodies' structures very different. The bodies of spiders are divided into two parts. The head with a fused thorax, which is all one structure, and the second part is a separate abdomen joined to the large head-thorax part by a narrow stalk. The head contains what many researchers now believe is a highly developed brain. There are no antennae, but 4 pairs of eyes and 8 legs covered with fine, sensitive hairs more than compensate for the absence of the antennae. These hairy legs and feet explore the environment, sending sensory messages back to the brain. Okay, the abdomen. Remember, that's the second part of the spider. It includes not only the digestive and reproductive systems, but also the silk glands that allow spiders to spin their webs. So, as you see, even though spiders and insects are commonly grouped together as bugs, they're really not the same. An oversimplification is that spiders have too many legs and not enough wings. In reality, the entire body's structure is quite different.
Describe the structure of an insect and explain why a spider is not strictly considered an insect.
Please prepare your answer after the beep. Please begin speaking after the beep. Number 5. Listen to a short conversation. Then listen for a question about it. After you hear the question, you have 20 seconds to prepare and 60 seconds to record your answer.
Now listen to a conversation between a student and his friend.
Can you believe that I've been here almost a whole semester and you're the only friend I've made?
No. How can that be?
I don't know. You know me better than anyone here at school. I thought maybe you could give me some advice.
Sure. Well, do you belong to any clubs or any organizations on campus? That's always a good way to meet people.
No, I don't have a lot of time to, go to meetings.
Well, neither do I, but I do play intramural sports.
What's that?
It's just a group that meets regularly to play basketball. Of course, there are lots of other teams besides basketball, I mean. You could join a football team or soccer, baseball, volleyball. Just go over to the recreation center and sign up. They'll put you on a team. You could use some time away from the books.
I'd like to do that, but...
Well, since you don't want to take time away from your studies, why don't you join a study group or get one going in one of your classes? That way you wouldn't feel like you're wasting time. And besides, the people you meet will be serious students, so maybe they'd be better friends for you anyway.
Describe the man's problem and the 2 suggestions that his friend makes about how to handle it. What do you think the man should do, and why?
Please prepare your answer after the beep. Please begin speaking after the beep. Number 6. Listen to part of a lecture. Then listen for a question about it. After you hear the question, you have 20 seconds to prepare and 60 seconds to record your answer.
Now listen to part of a lecture in a psychology class. The professor is discussing the Skinner box.
There have been several references to the Skinner box in your textbook because a lot of behavioral modification experiments still use similar devices even today. So let's just take a few minutes and make sure that everyone understands exactly what a Skinner box is and how it works. The box, which was named for B.F. Skinner, the American psychologist who developed it, it was used in Skinner's original experiment in 1932. And its construction hasn't changed much from that time. It's just a small, empty box, really, except for a bar with a cup underneath it. So picture this. In Skinner's experiment, a rat that had been deprived of food for 24 hours was placed in the box. As the animal began to explore its new environment, it accidentally hit the bar, and a food pellet dropped into the cup. The rat ate the pellet and continued exploring for more food. After hitting the bar 3 or 4 times with similar results, the animal started hitting the bar with intention instead of by accident. It had learned that it could get food by pressing the bar. In other words, the food stimulus reinforced the bar-pressing response. So, many psychology experiments were modeled after Skinner's original research. Various animals have been placed in modified Skinner boxes and presented with conditions that will result in a reward, food or some other desirable object or experience. In most of the behavior modification experiments in your book, you'll see a citation for Skinner's classic study.
Using the main points and examples from the lecture, describe the Skinner box, and then explain how the device is used in psychology experiments.
Please prepare your answer after the beep. Please begin speaking after the beep. Model Test 6, Writing Section.
First, read the passage on page 454 and take notes. Now listen to a lecture on the same topic as the passage that you have just read.
Most textbooks that have been published within the past 50 years include the Miller-Urey experiment because it was such a groundbreaking discovery at the time, and researchers honestly believed that they were on the verge of discovering the origin of life. But the current view of the Miller-Urey experiment is, let's say, skeptical. And there are several serious objections that we really need to deal with before we move on. First, the laboratory atmosphere that Miller and Urey created was charged with continuous electrical energy, but even though the atmosphere of early Earth was subjected to frequent electrical storms, they were probably not continuous. So, some scientists argue that although amino acids and other organic compounds may have been formed in the early history of Earth, they probably would not have been produced in the amounts seen in the experimental environment. Some scientists are also concerned about the fact that oxygen was reduced from the atmosphere in the Miller-Urey experiment. What if the premise that the mixture of gases simulated that of early Earth were false? Then, of course, everything else in the experiment is flawed. And here's another problem. Because several meteorites have fallen to Earth since the publication of the Miller-Urey experiment, there has been interest in analyzing them for amino acid content, and amino acids have been found in them. Well, that proves that amino acids are able to survive in severe conditions in space. So what does that mean? Some scientists think that the early Earth was similar to asteroids and comets that contain amino acids, so they may have been present from the moment that the Earth was formed. Others point to the possibility that organic compounds escaped from within meteorites in impact sites where they hit the surface of the newly forming planet Earth. The truth is that we just don't know how the first cell was formed, and we really aren't sure how that cell reorganized into larger living structures. So, although the Miller-Urey experiment is interesting, it probably does not hold the promise of unlocking the mystery of life on our planet.
Model Test 6, Example Answers.
Example answer for independent speaking question 1. A good son or daughter.
The role of a good son or daughter changes over the years. Initially, being an obedient child's probably all that a parent requires. But when a child grows up and begins to become independent, then a good son or daughter is a person who has good character, who does well in school or succeeds in a career and demonstrates the personal qualities that the parents have tried to teach. A good son or daughter is also a good parent when they have children of their own. When parents see their grandchildren being brought up well, they know that they've provided a good example. And And when the parents become old and need care, a good son or daughter won't be too busy to spend time with them and provide them with help.
Example answer for independent speaking question 2. Job opportunities.
Although a job that involves travel seems glamorous to people who spend day after day in an office, it really isn't for me. For one thing, traveling for business usually means going to the same places repeatedly and staying in the same tired hotel rooms. Besides that, the pace of a business trip doesn't allow much time to see anything besides the inside of an office building and the road to the airport. And eating in restaurants isn't that healthy, and traveling all the time is exhausting. No, I'd rather have a job opportunity that would let me sleep in my own bed and eat my own cooking. But ideally, the job would also include a 3-week paid vacation, so I could travel to a destination of my choice and relax.
Example answer for integrated speaking question 3. Excused absence.
According to the professor's policy, students can be absent from one class without explaining unless there's a test scheduled. And then the professor expects students to go to her office to give her an explanation for being out of class and arrange for making up the test. Also, being absent more than once could mean that your grade could be lowered by 1 letter for each time you miss class. The student doesn't agree with the excused absence policy because he thinks that his grade shouldn't be affected by absence if he makes up the work. From his point of view, a valid reason for absence, like an emergency, a family problem, or illness, that shouldn't jeopardize his grade unless he fails to keep up with the class or his work's unsatisfactory.
Example answer for integrated speaking question 4. Insects.
Insects are arthropods with a 3-part body structure: a head, a thorax, and an abdomen. The head has a pair of eyes and a pair of antennae, and 3 pairs of legs and 2 pairs of wings are usually attached to the thorax. Now, although a spider is also an arthropod, it isn't considered an insect, because it only has a 2-part body structure. The head and the thorax are joined together on a spider and attached to its abdomen by a thin stem. And a spider doesn't have antennae, but it does have 4 pairs of eyes. Instead of 6 legs, it has 8 hairy legs that are used kind of like an insect uses its antennae to explore the environment. A spider doesn't have wings. It has a unique glandular system that allows it to spin its webs. So, because of this very different body structure, a spider's not really an insect.
Example answer for integrated speaking question 5. Meeting people.
The man's problem is that he hasn't been very successful meeting people and making friends. He's been on campus for an entire semester, and the woman's the only friend he has. She suggests that he participate in some clubs, but he's reluctant to spend the time required for meetings. The woman plays intramural basketball. She says that there are a lot of sports options at the recreation center. Another possibility that she recommends is for the man to join a study group. That way, he'd meet some serious students, and he'd still be using the time to study for classes while he was getting to know people. I think that the man should join a group to play sports for an hour, twice a week, because he probably needs the exercise, and he should also try to get into a study group, because he'll probably have more in common with the people who are using their time to study for their classes.
Example answer for integrated speaking question 6. Skinner box.
A Skinner box is a small box that's empty except for a cup and a bar. When the bar over the cup's depressed, a food pellet drops into the cup. An animal that's placed in a Skinner box will explore the environment for food and at some point will accidentally hit the bar, releasing the pellet. So, after the animal hits the bar about 3 or 4 times and it's rewarded with food, then it learns how to find food using the bar, and it begins to hit the bar on purpose. The Skinner box, or something like it, it's commonly used in psychology experiments that involve behavior modification. By presenting a subject with the opportunity for a reward, the behavior that produces the reward is reinforced. In the case of the classic experiment, The subject's opportunity for a reward is a food pellet, and the behavior that's reinforced is pressing the bar. But many types of rewards and behaviors have been used.
Model Test 7, Listening Section.
The listening section tests your ability to understand spoken English that is typical of interactions and academic speech on college campuses. During the test, you will respond to conversations and lectures. This is the long format for the listening section. On the long format, you will respond to 3 conversations and 6 lectures. After each listening passage, you will answer 5 to 6 questions about it. Only 2 conversations and 4 lectures will be graded. The other conversation and lectures are part of an experimental section for future tests. Because you will not know which conversations and lectures will be graded, you must try to do your best on all of them. You will hear each conversation or lecture 1 time. You may take notes while you listen, but notes are not graded. You may use your notes to answer the questions. Choose the best answer for multiple-choice questions. Follow the directions on the page or on the screen for computer-assisted questions. Click on Next and OK to go to the next question. You cannot return to previous questions. You have 25 to 30 minutes to answer all of the questions. A clock on the screen will show you how much time you have to complete your answers for the section. The clock does not count the time you are listening to the conversations and lectures.
Listening 1, Professor's Office.
Listen to a conversation between a student and a professor.
Okay, Chris. Do you understand why I asked you to see me?
I guess so. I did something in class. I apologize.
But do you understand what's bothering me?
No, not really. I like your class.
I'm glad you do. But, Chris, you're disturbing the other students with your constant talking.
I am?
Yes. I've had several people complain about it. They're missing key parts of the lecture because you're talking.
But I'm talking about the lecture. I'm not just making conversation.
Look, Chris, it doesn't matter. When I am talking, you should be listening.
Well, I'm sorry. Sometimes I don't get a word or a phrase, so I ask someone about it.
Okay, I really don't think you're creating a disturbance on purpose. If I did, I'd simply ask you to drop the class, period.
Oh, please don't do that.
That's not my plan, but it has to be an option. Look, maybe you need to record the lectures. I don't mind if you do that. Then you can fill in the blanks when you listen the second time instead of asking your neighbor during the class.
That's a great idea. I really wanted to do that, but I was thinking you probably wouldn't want me to.
And another thing. If you have questions, I need you to write them down and make an appointment to talk with me about them. That's why I have office hours twice a week. Just call the department and we'll arrange a time.
Excuse me, Dr. Pierce. Can I tell you something? I'm embarrassed to ask you questions.
Why in the world would that be? I ask for questions at the end of every lecture. I encourage students to use my office hours.
I know you do. It's just that where I went to school before I came here, if you asked a professor a question, it was an insult because it implied that he hadn't explained everything well. You see, if the professor does a good job on the lecture, everything will be clear and no one will need to ask a question.
I see. Well, it's different here. I'm not saying that your other experience is wrong. I'm just saying that we do things differently at the university in this country. In my class, I don't expect you to understand everything in the lectures, and I don't take it as a challenge when someone asks a question. I view the question as kind of a compliment, because it means that person is very interested and is really trying to learn. That's the kind of student I want.
So I can ask you questions in class?
Or in my office. Just don't ask other students questions while I'm trying to give my lecture. That does upset me.
Oh, Professor Pierce, I'm so sorry. I was trying to be respectful. I'm interested in the class and I want to know everything.
I see that. Now I'm asking you to show your interest and respect in a different way. I want you to ask me the questions at the times that I provide for question and answer, at the end of the lecture and during my office hours.
And I can record the lectures?
Yes. Just don't make a lot of noise in class, okay?
Oh, no, I won't. Thank you so much.
1. Why does the man go to see his professor? 2. Listen again to part of the conversation and then answer the following question.
I like your class.
I'm glad you do. But Chris, you're disturbing the other students with your constant talking.
I am?
Why does the student say this?
I am?
3. Listen again to part of the conversation and then answer the following question.
I really don't think you're creating a disturbance on purpose. If I did, I'd simply ask you to drop the class, period.
Oh, please don't do that.
That's not my plan, but it has to be an option.
What does the professor mean when she says this?
That's not my plan, but it has to be an option.
4. How does the professor feel about questions in class? Five. What will the man probably do during the next class?
Listening 2. Art class.
Listen to part of a lecture in an art class.
Symmetry is a concept that, yes, is expressed in the graphic arts, but to understand its fundamental nature, we must go beyond art. We find symmetry in nature. It reverberates in music, translates into choreography for dance, and underlies basic mathematical formulas. But I'm getting ahead of myself. Let's begin with a dictionary definition of symmetry. And I'm reading here from the American Heritage Dictionary of the English Language. Symmetry is exact correspondence of form and constituent configuration on opposite sides of a dividing line or plane, or about a center or an axis. And it's also identified, in the same source, as beauty as a result of balance or harmonious arrangement. So we experience beauty and harmony when symmetry of form is expressed, and the form may be interpreted by any of the senses as harmonious. But in this class, we're going to focus on symmetry in the visual arts, and that's symmetry in a visual plane. Let's just look at some examples. In general, there are 4 types of symmetry in a plane, and a pattern is symmetrical if there's at least one type of symmetry. So let me show you the 4 types, since it's much easier to understand when you see them. This is rotation symmetry. For this example, I used the letter R, but any object could have been used. And in the rotation, the object, in this example the letter R, is turned around a center. In this case, there's a right angle, but any angle could have been selected. Reflection is... Wait a minute. Okay, here's the slide. Reflection is what we see in a mirror, so every reflection has a mirror line. A reflection of the letter R is a mirror image or a backwards letter R. So, unlike the rotation around a circle, this type of symmetry flips the object over. Here's a translation. To translate an object means that we move it, but we do it without rotation or reflection. It's simply placed somewhere else on the plane. And for our purposes, we're talking about a flat plane. So in this example, we just moved it over a little bit. Okay, this is my last example of symmetry, and it's referred to as glide reflection. This is the most complex type of symmetry because it involves 2 steps instead of 1. A glide reflection is a combination of a reflection and a translation along the direction of the mirror line. So you can see the 2 steps here. First, we flip it over, and then we move it somewhere else on the plane. Of course, these concepts can be generalized to include spatial symmetry as well. But symmetry on a flat plane involves positioning all points around the plane so their positions in relationship to each remain constant, although their absolute positions may be subject to change. To put it in simple terms, if an object looks the same to you after you spin it around, flip it over, or look at it in a mirror, then that object probably has symmetry. Symmetry is such a fundamental organizing principle that an object with symmetry can be identified without our being able to see the entire object. Our brains somehow piece together the missing pieces to form a symmetrical whole, which is really rather extraordinary when you think about it. At some very basic level, symmetry may be part of the way that we organize our thinking, and of course that would explain why it's so pleasing. So now, let's return to symmetry in art. Symmetry stands out and attracts attention. It's the system of organization for patterns. But what is a pattern? A pattern has three characteristics: a system for organization, and like we said before, this is often symmetry, but a pattern also has a basic unit. That is, it's an object that's the smallest discrete part of the image. As you'll recall from the types of symmetry that we discussed, the letter R was the basic unit. Okay, finally, a pattern has repetition, which can be the repetition of a unit or a group of units. And this repetition, in much of art, this repetition is arranged symmetrically. Just look around the classroom. Look at the tiles on the floor. Here you see a symmetrical design with 4 repeating tiles. The tiles were not placed at random. There's a pattern here with all 3 characteristics of a pattern. First, there's a unit, a basic unit of 4 tiles. Second, there's repetition of the tiles with solid tiles surrounding them. And third, there's symmetry within the 4 tiles, which, to be specific, looks like rotation symmetry to me. Now, for your studio assignment, I want you to draw a pattern that has as its organizing principle a symmetrical design. It can be either in color or in black and white, but it must fit on a piece of standard 8.5 by 11-inch paper. On a second sheet of paper, I want you to identify the type of symmetry that you used. Perhaps some of you will want to experiment with several types of symmetry, but if you do, please be sure to identify each of them clearly in your narrative. For this first effort, I recommend that you stick to something relatively simple, like the tile floor. So when you come to class next week, be ready to share your design with 3 other people in a group. Then I'll collect them at the end of the hour.
6. What is this lecture mainly about? Seven. Listen again to part of the lecture and then answer the following question.
We find symmetry in nature. It reverberates in music, translates into choreography for dance, and underlies basic mathematical formulas. But I'm getting ahead of myself. Let's begin with a dictionary definition of symmetry.
What does the professor mean when he says this?
But I'm getting ahead of myself.
Eight. Which of the following slides represents reflection symmetry? Click on the correct diagram. Nine. How is it possible to recognize an object when only part of it is visible? 10. In addition to a system for organization, what characteristics define a pattern? (11) What assignment does the professor give his students?
Listening 3. Biology class.
Listen to part of a lecture in a biology class.
By studying the fossil record, we can read the history of life on Earth. Interestingly enough, it appears that there are long periods in which not very much change occurs, then sporadic brief periods in which there are mass extinctions of species, followed by diversification of the groups that survived. How does this happen? Well, sometimes a habitat's destroyed or the environment changes. Did you know that if the temperature of the ocean falls by even a few degrees, many species will die? Incredible, isn't it? Or, even when the environment's relatively stable, biological conditions can change when other species evolve in different directions. For example, let's see, when a similar species evolves by developing a shell, then the related species without shells may be more vulnerable to predators and could become extinct as a result of changes in the other species. So you can see that extinction's a natural consequence of history. It's, well, inevitable. But sometimes mass extinctions occur and most of the known species are lost, and this is very different. Let me mention two such mass extinctions. First, the Permian mass extinction, which occurred about 250 million years ago. According to fossil records, more than 90% of the marine species and about 30% of the orders of insects perished. Then about 65 million years ago, the Cretaceous mass extinction claimed more than half of the marine species and many terrestrial species of plants and animals, including the dinosaurs. So what causes mass extinction? This isn't an easy question to answer. You see, it's obvious from the fossil records that species exist during a certain geological time period, and then they disappear. And we have solid evidence for that. But why they disappear is, well, more speculative. In the Permian, several extreme conditions may have converged, including the merging of the continents into one large landmass. As you can imagine, such a radical change in the distribution of land and water would have disturbed habitats and caused the climate to change. There's also evidence that volcanic activity during this period may have produced enough carbon dioxide to cause global warming, which in turn would have affected the temperature and depth of the oceans. And I'm referring here to global warming, so it probably also caused the oxygen levels in the oceans to decrease. All of these conditions could have converged to extinguish an enormous number of species at the same time. That's mass extinction. And a similar set of conditions may also have contributed to the mass extinction in the Cretaceous period as well. We can gather data that convinces us about continental drift, that it occurred along with receding seas along the continental coastlines. In addition, we know that cooler climate was probably the result, at least in part, of increased volcanic eruptions, and these eruptions probably released enough material into the atmosphere to block the sunlight. Having said all of that, many scientists now favor a very different hypothesis. They theorize that maybe a large asteroid collided with the Earth. Advocates of the so-called impact hypothesis speculate that there were two events that caused the mass extinction. First, the impact probably caused a firestorm of such proportion that most of the life in North America would have been decimated within minutes. Second, they postulate that an enormous cloud of fallout could have blocked out the sunlight, and that the impact was, in fact, large enough to darken the Earth. And we're talking about months or even years. So the result of the darkness, that would have caused a reduction in photosynthesis, which in turn would have created a disruption in the food chain. Now, such a disruption would have affected many species. So the advocates of the impact hypothesis, they put forward evidence that a thin layer of clay, rich in iridium deposits, can be found in the geologic material that separates the Mesozoic and the Cenozoic eras, precisely the time period for the Cretaceous mass extinction. So what's special about this clay? Well, iridium's a very rare element on Earth, but it's quite common in meteorites and other extraterrestrial debris that's been analyzed. So it's possible that this sediment is the remains of the impact. The fact that there was more serious damage to the species in the Western Hemisphere could also be explained by the point of impact. and the fact that the dust cloud could have caused more acidic precipitation nearer the area of impact. Or there may have been a number of calamities that converged simultaneously, disrupting planetary balances. But whatever the cause or causes, the fact remains that the mass extinctions occurred, and they influenced the biological diversity of our planet in profound ways. The species that survived, whether because they had genetic advantages or because they were fortunate enough to be farther from the catastrophes, these species became the ancestors of the species that have played important roles in biological evolutionary history.
12. What aspect of the fossil record is this lecture mainly about? (13) Identify the main periods of mass extinction. 14. Listen again to part of the lecture and then answer the following question.
You see, it's obvious from the fossil records that species exist during a certain geological time period, and then they disappear. And we have solid evidence for that. But why they disappear is, well, more speculative.
Why does the professor say this?
But why they disappear is, well, more speculative.
(15) What is the impact hypothesis? 16. What is the evidence for the impact hypothesis? 17. What can be inferred about the professor's opinion?
4. Students on campus.
Listen to part of a conversation between two students.
Hi, how'd your presentation go?
Really well.
See, I told you.
I know, but I was really nervous.
So what happened?
Well, the TA asked for volunteers to go first, and I raised my hand right away because I wanted to get it over with before I got any more nervous than I already was.
So you went first?
Yeah, and I used a lot of visuals. I had about 20 slides on PowerPoint, and that really helped me to stay on track. I mean, I didn't read the slides to the class or anything, but some of the titles kind of jogged my memory. So I knew what I wanted to say while each slide was shown.
That's the beauty of PowerPoint.
Of course, I'm always afraid the computer program won't work, and then there I am without anything. But I made overheads, copies of all the slides just in case.
So you could have used the overhead projector as a backup. Good idea.
And I had most of the stuff on handouts, so they could follow along without spending a lot of time taking notes. That way I could move along faster and get more in 10 minutes.
Yeah, 10 minutes isn't very long when you're trying to present something as complex as population density.
That's for sure. The maps really helped.
A picture's worth 1,000 words.
So true.
Listen, I can't remember whether you had a group or you had to present all by yourself.
You had a choice, but I decided to do my own presentation. I don't know. Group projects are really popular, but,
I hear you. I'd rather take responsibility for the whole presentation if I were you.
No surprises that way.
Is that one of your handouts? Wow, that looks fantastic.
It's easy. PowerPoint has an option for putting the slides on a handout.
Still, it looks so professional.
Thanks.
So, did you have any questions after the presentation?
Not really. I think people were mostly just wanting to get on with their own presentations.
But they seemed interested.
Oh, yeah. And the TA said something about getting off to such a good start. So I felt good about that.
18. What are the students discussing? 19. Which strategy does the woman use for her presentation? (20) Why did the woman make overhead copies of the slides? (21) Listen again to part of the conversation and then answer the following question.
You had a choice, but I decided to do my own presentation. I don't know. Group projects are really popular, but,
I hear you.
What does the man mean when he says this?
I hear you.
(22) Why didn't the class ask questions after the presentation?